Alright, so now we're going to talk about another application. Wow, I can't write. Application of root finding. And that is eigenvalues, eigenvalue problems. Okay, so before getting too far into this, let me just, I just want to motivate it a little bit. So you may recall, or if you're concurrently taking the class, you'll be learning. So here's a simple differential equation. You could say a2 d squared y dy dt plus a1 dy dt plus a naught y equals some forcing function, forcing function f of t. This could also be written as a2y double prime plus a1 y prime plus a naught y equals f at t. And if we're going to solve this system of equations, you may recall that there are different. There's the let's see, the general solution. And the particular solution, but let's just look at the general solution. If we look at the general solution, that's going to be the solution when f of t equals 0. So that's a 2y double prime plus a 1y prime plus a naught y equals 0. And if you remember, when we to find the solution to this, the solution is going to be let's see, a 2r squared e to the rt plus a 1r e to the rt plus a naught e to the rt, where r is a root of equals 0, where r is a root, so we can divide this all by e to the rt, divided by e to the rt. So we get to cancel all these guys out. Whoop, whoop. So that means a 2r squared plus a1r plus a naught equals 0. All right. So now we have what's called the characteristic equation. The characteristic equation. Well, I guess r's aren't the roots. Okay, so we have this characteristic equation. That's the characteristic equation, and this is a root finding problem. Hooray! So this is actually a polynomial root finding problem, and there are particular methods that come into play when we're trying to find the roots of a polynomial. There's sort of some special things that we do when we're trying to find the roots of a polynomial. But this is true not only for so the eigen. Well, anyway. So this is an eigenvalue problem. Solving the characteristic equation, that's an eigenvalue problem, and again, you can get into what eigenvalues are a little bit more in your differential equation class. We don't care that much, other than just to bring up the fact that eigenvalue problems are immensely important in engineering, and they come up all the time because they're based on differential equations, which we see all the time. The heat equation, the wave equation. In fluids, we see it as well. We see these differential equations all the time, and so it turns out a lot of times finding eigenvalues gives us at least part of the solution to these equations. And so, without further ado, then we'll get into some of the particulars. Particular methods that are well suited or customized for finding the roots of equations when we're working with polynomials, which is the case when we're doing an eigenvalue problem, or when we're solving, which is the same when we're solving the characteristic equation.